Hi guys, good evening everyone. Welcome to this live session. And in today's class, I'll be talking some important concepts regarding the flip-flop conversions. Okay, so let me see these things. Yeah. So if you have any questions regarding today's class, we'll be dealing with the flip-flop conversion. So we have a lot of flip-flop conversion questions coming in exams nowadays days, right? So in order to tackle that problem, I have come up with this particular course on YouTube channel. Okay, so you can find the entire digital electronics course on the Unacademy Plus category. So if you want, in case if you have to check it out, if you want to see more things regarding these digital electronics, do check out my Unacademy Plus category. And not only these digital electronics, I have also made the packed all the complete courses on analog electronics as well. Okay, you can find that in analog electronics. You will see that analog electronics. And not only analog electronics, I have also made a course on power electronics as well. Okay, so regarding the power electronics and analog electronics also, I have made the courses complete courses. They are just for aspirants. So if you are a true aspirant who are exactly preparing for the gate exam, or if you are combating for the SSC JE and other exams, these courses are exactly designed for you. All these courses are power packed course. Like I have taken around 28 to 30 days each, that means 28 to 30 hours for discussing about only single subject. Okay, have given about analog electronics, power electronics as well. Okay, do check out other courses as well. Measuring instruments also I have provided the course. Okay, so measuring instruments, electrical measuring instruments. Okay, so you can find all these things. And in case throughout this course on today's class, what I'll be talking about flip-flop conversion. If you have any doubts regarding today's class regarding the flip-flop conversion, do message me in the comment section below. I can just see the comment sections over here. Okay, so whenever you have doubts, something like that, just message me over there in the comment section below. Okay, I'll be looking into that. Fine. So I'll just check out this comment section right now, so that I'll see whether anyone is having doubts regarding the so far discussed said things. Okay, fine. So let's see what is this particular course, today's specialty course. What is the important thing we are talking exactly here? Let's try to understand that. Okay, so this course is presented by me, Anvesh. I'm one of the top educators in the GATE Electrical Engineering for Unacademy. I have been teaching right now from around 4 years, and I have good expertise on these knowledge on electrical engineering, and I have done a graduation from SRM University, and also have holds a master's degree in power engineering. Okay, so you can read more about me on the internet too. Okay, I think most of you might know about my all the introduction about me, right? So you can find out me on the Quora if you want. You can ask me questions, all this stuff, important stuff, and you can ask me anything on the other platforms too. But right now I'll be active on an academy platform. Okay, you can where you can lively interact with me using the special classes, using the plus courses. All the plus courses, I'll be regularly in touch with who are having the plus subscription. Okay, so the important thing is do get the subscription. That will be really helpful for the gate exam. Many people are right now getting this opportunity. Right now they are having this power of interaction, and they are having the digital data, everything, right? So all the classes running right now, mock test, everything, all the things are provided on the Unacademy Plus category. So do check it out. It will be really interesting and you will love that feature. Okay, fine. So coming to today's concept, we are just talking about some important flip-flop conversions. Okay, I'm just checking you guys comments. If you have any doubts, do let me know in the comment section. Okay, now we have various flip-flops. I have talked about all the flip-flops in my plus course. Okay, you can see the schedule of the plus course. This is Unacademy Plus course. You can see here, this is the Unacademy Plus. So this is exclusively on Unacademy Plus. Okay, so this is on Unacademy Plus itself, and you can find the digital electronics course I have already completed. Okay, so most of the time I have dealt with the basic parts. See, just look at the combinational circuits and sequential circuits. All these things I have allotted lot of duration, lot of hours dedicated for these circuits, combinational circuits, sequential circuits, even the number system also. I have given n number of practice problems. I have solved them in the class. I have given you what is they exactly telling. Okay, so if you have a zero knowledge on digital electronics also, you can just build up all the important concepts, your basics, each and everything from my special classes and my plus courses. So get the subscription and do check out what is the course structure I have already provided on Unacademy Plus. That will be really useful for you. Okay, and I can assure you that using this knowledge what you have gained on this Unacademy Plus, you can gain crack most of the exams what you have applied for so far. Okay, fine. So the coming to the questions part, so whatever the questions I am discussing, whatever the weekly quizzes we have in these sessions, all these weekly quizzes questions are taken from the previous year questions, and some good concepts which can be expected in the coming gate exams or something like that. I have included them in the weekly quizzes and also in the mega quiz sessions, fine. Okay, so if you have any doubts regarding these things or these courses, just let me know what is your doubt in the comment section, so that it will be easy for me to tackle what exactly you are dealing with. Okay, fine. So let's see what is that important flip-flop conversion. What are we exactly talking about here? See, the thing here is we need to convert one flip-flop to another flip-flop. So exactly what are we doing? Suppose if I have an SR flip-flop, I need to build a JK flip-flop using this SR flip-flop. Okay, but I don't have JK flip-flops available with me. So if suppose you don't have SR JK flip-flops available in the market, you need to convert that SR flip-flop to the JK flip-flop. You can do that. So how do we exactly convert this? Okay, so how do we convert the SR flip-flop to JK flip-flop? That means how am I utilizing the SR flip-flop to make it function like a JK flip-flop? Okay, so if you look at the flip-flop constructions initially, then you will get an understanding. Okay, so if you see the construction of the flip-flop, so let's try to see one simple conversion. If you have a lot of equations based on the flip-flop conversions in the exams as well. Okay, so in the conversions, if I'm talking about converting from SR to JK, so if I want to convert from SR flip-flop to the JK flip-flop, how do I exactly do that? So to understand this, first of all, you should have a clear idea on what is SR flip-flop first of all, and how is it made up of. So if you are generally the SR flip-flops are made up for using the NAND latch. Okay, so using the NAND latch, I have built up already an SR flip-flop. So using these NAND gates, I am building some SR flip-flop. But important thing is, I have already given you the data, whatever the important classes related to the SR latches in the previous class. Okay, so do check out my previous courses on the combinational circuits and the sequential circuits. You'll get clear idea about what are these gates and everything. Okay, so in the flip-flop parts, I have discussed about these things. What are these flip-flops and what are these NAND gates, what is latches, everything I have given. Okay, so if you don't know these courses, if you don't know these terms, what is flip-flop and how am I connecting exactly, and what is how to draw the truth table of particular flip-flop, you can just see that in the section. So already I have provided you lot of sections over there, a lot of discussions are there based on these things only. Okay, so do check it out, that will be useful. And coming to this discussion right now. Okay, if you have any doubt, do let me know in the comment section. Okay, do let me know that. Fine. So in this SR to JK flip-flop conversion, what you should be first having? Let's see the SR flip-flop. So first you need to have three important tables. To have any conversion, you need to have three. You need to understand three important tables. What are those tables? Let's see that. The first table is you need to have you need to know about truth table. You should be able to construct a truth table. You should be able to construct characteristic table. Okay, characteristic table. Then you need to you should be able to make excitation table also. Okay, so what are these tables? First of all, let's try to build these tables for SR flip-flop. Okay, similarly we will build these tables for the JK flip-flop, and then we will try to convert SR flip-flop to the JK flip-flop. Now in exams, I'm telling you guys, I'm telling you this conversion, basically the conversion of this flip-flop to another flip-flop. It's very easy process, but it may be little confusing if you remember it in a different way, but if you just go through with the the process all I will be discussing right now, you won't be having any confusion with that. Okay, with the conversion with anymore. In the next, from the next question onwards, if you see these conversion questions based on conversion, if you see any question in the exam, you can directly convert there itself using this method. Okay, so that is the easiest method right now. You can see for the SR flip-flop and the JK flip-flop conversion. I'll give you an example on that. Okay, so let's see. First of all, let's look at the truth table of SR flip-flop. Now if you look at the truth table of SR flip-flop, what did we discuss about the SR flip-flop? We have seen it already. This is the SR truth table. You can see initially if I have the clock 0, if I have the clock 0 and S value and R value, I don't care what the S and R values are there given to the flip-flop. What will be the Q? The Q will be the memory, whatever the memory I have stored so far, it won't be changing. So the Q output is going to be the no change or generally memory. So in some textbooks you will be seeing NC or no change. It is nothing but memory. Okay, now suppose if clock is high, so the clock is right now is high 1 and I'm giving S value as 0 and R value as 0. So 0001 1011, this is what I'll be giving to the S and R, right? And initially for clock 0, I don't care whatever the S and R value are, I'll be having the output as memory only. Okay, that is fine. But what about in this case, the first case of 00, whenever the S and R are 0, the initial case will be having the output as whatever the memory will be having. So therefore I'll be calling it as memory or no change. Okay, now in the next case I have the clock input as high. So throughout this operation I'll be having the clock input high. Okay, I'll keep that high itself. See, it is high for the throughout the operation, and 0001 1011, these are the inputs given to the S and R. Now suppose if I'm having 0 and 1, what will be my Q right now? I have already described you the SR flip-flop operation. The Q will be 0 if S is 0, right? So I'll have Q0, and that is what Q0. So I can clearly say this is what I'll be having at the next state. So I'll be writing Q as 0 and Q complement is complement of that 1. Okay, and S is 1, R is 0. In this case, whenever S is 1, I'll be having Q as 1. So I'll simply write Q as 1 and Q complement is 1 complement is 0. So therefore 0. Okay, and when clock is 1, S is 1, R is 1. Now whenever S and R are given 1, what is happening? We are seeing that Q is basically metastable. That means Q is trying to equal Q complement. So which is not at all possible. So therefore it is not used, or metastable condition we will be calling that. Okay, so it is invalid, or some people say prohibited. So some textbooks say different, use different words like that. Don't get confused. Metastable or invalid or not used, everything is same. We generally give it for S1 and R1. So we do not use that. Not used, we generally call it as. Okay, I'll call it as not used. Fine. So this is what I'll be drawing the truth table. Now see what is Qn plus 1. So Qn, I'll be calling this as Qn, and this is the past output I'll be having. So Qn is basically nothing but a memory. I'll be saying that. Okay, so I can clearly say Qn is past output or past state. So Qn plus 1 will be the next state. So Qn plus 1 is going to be Qn only, which is nothing but memory only when S is don't care, R is don't care, right? So whenever the clock is 0, I don't care what S and R are, but the next state, whatever the next state is going to be there for the next clock pulse, what will be the output? The next state will be the whatever the memory I'll be having. So therefore I'll be writing whatever the memory is nothing but Qn. So whatever the Q itself, right? So therefore I'll say Qn is nothing but memory. Qn is the next state going to be. I won't be having the change in the next state. Okay, output is not going to change. No change in the output, I'll be calling that. Fine. So what is whenever I have clock 1, S is 0 and R is 1, I have the Qn as 0. What will be the next state going to be? The next state is going to be 0 only, right? So I'll have that 0 over here, and similarly I'll be having 1 over here in the next state whenever I have S1 and R0. But what is happening in the next state whenever I have S is 1 and R is 1? It is becoming metastable. That is the reason we are calling it as metastable. So Qn is trying to become Qn complement, or you can say 1 is trying to become 0, which is not at all valid. It is obviously against the nature. So therefore I'll call that as invalid cases, okay, or metastable cases. So this is what we have to construct, how we have to construct a small truth table. Now you have the truth table, and what I'll be doing right now is using this truth table and using this characteristic table, I have to build up the excitation table. So till here I'll say that from this point till this point it is basically called truth table, and the total table is basically called as the characteristic table. Now why do we call it as characteristic table? In the sense, we are finding the characteristics of the SR flip-flop. Okay, so by drawing this truth table, I have a till Qn and Qn complement only, but extending that to write Qn plus 1, I am finding what is the characteristics of this flip-flop going to be. So SR flip-flop characteristics says that when S is 1, R is 0, the next state is going to be 1. So I can find that characteristic from this characteristic table. Therefore I am calling this as characteristic table. Okay, so don't get confused in exams. I'll tell you in the conversion we have a small terminology related stuff. So that's the reason I'm giving you clear explanation of why it is called as characteristic table. Okay, I'll tell you easily, you can easily remember that how to convert. Okay, now fine, I have a truth table, and from here to here I have the excitation table, the characteristic table. Now I need to plot the excitation table, right? So what is exactly characteristic table? So in exam if I have till this point I have the truth table of SR flip-flop, I need to build the characteristic table. So what I'll be doing is, I'll be considering S value, R value. So this is the truth table I told you, right? This is the truth table I have. I need to write the characteristic table. How do you exactly write the characteristic table? I need to find the Qn plus 1 using Qn, S and R. So using these three, I need to find this Qn plus 1. What is the Qn plus 1 going to be? I need to answer that. So how do I get that solution? How do I get this answer, Qn plus 1? So first of all, we need to write the Qn values, S values and R values. I need to fill up the input, so then I'll be having the output. Okay, so let's see that how is that possible. Okay, see, I'll be taking here, so Qn is basically 0 in this case, right? So Qn is 0 means Qn is 0. I'll be taking it in the 4 cases. Why I'm taking here is how to fill up this characteristic table. First of all, see, 0 0, S and R are written over here, 0 0 0 1 1 0 1 1. Write the SR values like this, and take Qn as 0. The memory can be 0 or memory can be 1, right? We don't know what is happening in the memory, what is there in the memory. Qn is nothing but past states or past outputs or memory, you can say that. So past Qn is nothing but past output. Past output we don't know, it can be 0 or it can be 1. So when S is 0, R is 0, the Qn can be 0 or it can be 1 also, right? So that's the reason what I'll do is, I'll take S value 1, R value 0, okay, and then I'll take Qn value as 0. So again, S value 0, R value 0 and Qn is 1 right now. Like that, I'll be taking 2 cases for each S and R value. So S is 0, R is 0, I'll take 2 cases of Qn when Qn is 0 and Qn is 1. Like that, for S is 0, R is 1, Qn is 0, Qn is 1, S is 0, R is 1. So like that, I'll have how many cases right now? 8 cases. 1, 2, 3, 4, 5, 6, 7, 8. So I'll have 8 combinations right now. I can say 8 states are there present in this table. 8 states, this one state, like that. Okay. Now I need to, okay, I have given the, made the input part and everything, and how do I find out the Qn plus 1? See, I have a S and R values 0 0, Qn is 0. Qn is 0 and S and R values are basically 0 and 0. What are we trying to do here? When Qn is 0, what I'll be getting at the output? I'll be having the next state is nothing but 0 only. The next state Qn plus 1, Qn is 0 and these values S and R values are also 0. So basically I have a memory over here. So Qn plus 1 is nothing but Qn, right? So Qn plus 1 is nothing but Qn. When S is 0, R is 0 and Qn is also 0, I have Qn plus 1 is nothing but Qn. What is Qn? Qn is 0. So therefore Qn plus 1 is Qn, which is nothing but 0. Okay, I'll simply write this as a Qn plus 1 as Qn, but Qn value is 0. Similarly here also S is 0, R is 1, right? So you just leave this and try to see this case. In this case S is 0, R is 0, same as the first case, but I have Qn as 1. The next state will be Qn only, but what is the Qn? Qn is not 0 right now, it is 1, so Qn value will be 1. Like that, S is 0, R is 1, Qn value is 0. S is 0, R is 1, Qn value is 0. Qn value is 0 means this value is 0. S is 0, R is 1, Qn is 0. What I'll be having at Qn plus 1? I'll be having Qn plus 1 as 0. I'll be having Qn plus 1 as 0, right? So Qn plus 1 is 0. That is what I have written. Similarly, S is 1, R is 0. I'll be having 1 0, right? S1 R 0. S1 R 0. Qn value is also 0. So S1 R 0, Qn value is 0 in this case means what I should be taking exactly? Qn1, S is 1, R is 0. A Qn value is 0, obviously. It will be the same as what the complement we have taken. Qn plus 1 will be 1 right now. S is 1, R is 0. That is the case going to be. Okay. So in this way, I'll fill out all the rest of the states as well. Rest of the states can also be filled out. So you can clearly see S is 1, R is 1. I don't care what the next state will be there. I'll be writing it as don't care here. Okay. So I'll be taking them as don't care. S is 1, R is 1 cases meta valid, right? Metastable, right? Invalid. So S is 1, R is 1. The Qn plus 1 is invalid or metastable. I'll just keep it as don't care over here. Okay. Now from this I need to make the excitation table. So how do I do that exactly? Okay. So how to write this excitation table? What is excitation table? First of all, we need to understand. So excitation means, what is excitation? In excitation is nothing but input. Okay. In just remember this, that this important thing. Find the inputs of flip-flop. So if it's a SR flip-flop, I have a SR flip-flop, right? So S and R are the inputs of the flip-flop. I need to find the S and R of the flip-flops using the so far known values. But what are these so far known values for the finding this excitation flip-flop of this SR flip-flop? So how do you do that exactly? In excitation table, I have S and R. Those are the inputs. I have to find out those S and R. How do I do that? So first try to see the table itself. How do we draw the table here? I'll take Qn plus 1 with so far known data only I have to construct. That means using Qn and Qn plus 1, I can find out S and R, right? Because I already have a characteristic table. From the characteristic table, I am making an excitation table. See, Qn will be there and this is Qn plus 1 will be there, right? And we have S and we have R. Okay. So the Qn and Qn plus 1. Now see, I'll write the Qn and Qn plus 1 values 0 0, 0 1, 1 0, 1 1. Okay. So these are the 4 states I can have assigned for Qn and Qn plus 1. So for 0 0, Qn is 0, Qn plus 1 is 0. What do I exactly have? Qn is 0, this is 0, right? and Qn plus 1 is 0. Okay, this is also 0. So these two cases basically have Qn 0 and Qn plus 1 as 0. Now tell me, in these two cases, what is the value of S and what is the value of R? I have the S value constant as 0 itself. Okay, I'll have it as constant. Let me change the pen ink. Okay, I'll have a S value as constant 0, but my R value is changing from 0 and 1. So I don't care about R value because it is changing to 0 and 1, but I care about S value. S value will be 0 always whenever I have Qn as 0 and Qn plus 1 as 0. Okay, I don't care about R can be 0 or can be 1, it can be anything. Okay, but S value must be 0. That is what we have found out using Qn and Qn plus 1. Just by looking at the past outputs and the next outputs, next state, I am finding S and R for that. So if I provide S equals to 0 and R can be anything, if I am giving R as 1 or R as 0, then I'll have the next state as 0 only. That is what the excitation table is telling us. Okay, so 0 and 1, whenever Qn is 0 and Qn plus 1 is 1, Qn is 0 means this is Qn is 0 and Qn plus 1 is 1. So this is case 1. So Qn is 0, Qn plus 1 is 1, and we even have Qn is 0 and Qn plus 1 as 1 in this case, right? See, even here also I can clearly say that what is the value of S and R going to be? S value is nothing but, do you have any doubts? Do comment me over here, I'll see that. See, S value is 1, and what I have here, see, S value is 1. How is it 1 in the sense? Take this Qn equals to 0, right? I even have Qn plus 1 as 1. In this case also, don't care can be 0, don't care can be 1, right? So it can be either 0 or it can be 1 also. So I'll take the condition when Qn plus 1 is 1, and when Qn plus 1 is 1, I'll take this state into the consideration. Now tell me, S value is not changing, S value is 1, and what is the value of R going to be? R value is changing from 0 and 1. That means, what is the R value? R value is the don't care for this condition. I can say that. So that is the condition. But does it happen exactly like this in the SR table, excitation table? No, it doesn't happen like that. Why is it not happening? We are not considering these don't cares. We are not considering at all these don't cares. I'll take the R value as 0 itself in this case. Okay, I won't be considering. Okay, don't get confused in exams also by looking at these important things. I have a don't care. It cannot be 1. Okay, it cannot be 1. Fine. Where are we? Yeah. See, I have R value 0, S value as 1. So this is what I have got from the 0 and 1 state. 0 and 1 state. Now tell me guys, do you have any so far, do you have any problem with these things? No problem, right? I'm just checking with the comment sections. Fine. So let's proceed with the table. Qn is 1, Qn plus 1 is 0. Qn is 1, Qn plus 1 is 0. Tell me what is it going to be? S value is 0. Why is it 0? Because Qn plus 1 is 0. Qn is 1. Qn is 1 means this is the 1 case. Qn is 1 and Qn plus 1 is 0. Right? Now in this state, tell me, What's the value? What's the value of S? What's the value of S and what's the value of R? S value is 0, R value is 1, nothing else, right? S value is 0 because 0, R value is 1. And tell me what is happening in the last case when Qn is 1 and Qn plus 1 is also 1. I have these two cases, right? Qn is 1, Qn plus 1 is also 1. Qn is 1, Qn plus 1 is also 1. I have R as 0 and S as don't care, right? S as don't care and R as 0. So this is the excitation table. This is the excitation table. How do we find out this excitation table? Find it from the characteristic table. So basically you will be converting it from this particular table to this table. Okay, so from there you will be able to convert that into excitation table. Okay, now how do we convert this particular flip flop to another flip flop? Means same table you must be able to draw for the JK flip flop also. So if you have these three tables, if you are capable of doing constructing a truth table, constructing a characteristic table, constructing an excitation table, then you can convert any flip flop into, you can represent that in any other flip flop as well. Okay, so if you want to convert from SR to JK, what are the steps I should have? First of all, let's see that. Okay, so to understand that, let's see what is JK flip flop first of all. So this JK flip flop is basically like you can say extension of the SR flip flop. I can say everything is same, but only one important thing in SR flip flop. What is happening? We have this truth table, and I'm not utilizing this metastable state in the SR flip flop, right? See, when S is 1 and R is 1, I'm having a metastable state where Q is trying to become Q complement, right? So that is not against that metastable condition. That is the metastable condition. That, so I want to, I'm not utilizing this metastable state, right? So I am not utilizing that, so I want to utilize that. Therefore I'll just slightly modify this SR, and I will make a JK flip flop right now. And what with this JK flip flop, what I am trying to do is I'm making this Qn plus 1 of metastable state. That is, whenever S is 1 and R is 1, everything is remaining same, but only one important thing in the JK flip flop, when S is 1 and R is 1, that means the J is 1 and K is 1, what we'll get at Qn plus 1 is, we are getting the complement of Qn. Okay, so complement of Qn will be there, toggling will be there. So that is the only difference. I already talked about this toggling in the JK flip flop lesson. Do check out the explanation on this JK flip flop. It will be easy for you on the Unacademy Plus. So do check out my course already. I have already made a lot of courses on this. So do check out how the toggling is coming out and what is the difference between toggling and race around condition. And in exams, if your questions are based on race around condition, how to answer that I have already given you detailedly. Okay, so do check it out, and don't forget to get the subscription, because if you are not using the subscription, you won't be getting that price. Okay, if you won't be able to look at all these important stuff in the place category as well. Okay, so do check it out. And what I have given there is the JK flip flop construction, and how is it running, and how are we getting race around condition in the JK flip flop, completely in exam point of view only. Okay, so what we are avoiding here is, I'm trying to avoid or evade Q equals to Q complement case. That is where I'll be having the metastable state, right? So I'll try to eliminate that Q equals to Q complement condition. So I'll be having Q is equals, the next state, the Qn plus 1 is basically the complement of the Qn. So the next state, what is the next state? 0. This 0 is basically the complement of the previous state. So again, like that, I'll be having over here in the toggling state. See here, this is where the race around condition is coming effect. 0 1 1 0 1 0, like that it is going to be toggling. So the next state is a complement of previous state. 0 is complement of 1, 1 is complement of 0, like that it's basically toggled Okay, that is what we have achieved in the JK flip-flop. I already talked about that in the plus classes. Okay, so do check out my courses, that will be really helpful with you. Now let's see how are we exactly converting that to JK flip-flop. Now to get that, what are the things we essentially require in JK flip-flop? Now in JK flip-flop, I'll give you the truth table. Okay, if I want to see the truth table, okay, this is what the truth table. It is same as it is like for SR flip-flop. Okay, so this is basically the JK truth table. Okay, so this is the JK truth table. And in the SR, everything is same. At the last state we have metastable state, right? Qn plus 1 is metastable. Now here I'll be having JK, everything is same, Q complement, everything is same, but only the last thing here I'll be having race around condition, that is the next state. Qn plus 1 will be Qn complement. So that Qn complement toggling is what I have seen in the master slave condition. Already we have discussed master slave, right? So to avoid this race around condition, we are using master slave combination of the JK flip flop. So what I'll be getting here is, only difference between SR flip flop truth table and the JK flip flop truth table is, at the end in the metastable state, instead of having a metastable state, I'll be having Qn plus 1, the next state, as Qn complement instead of the metastable. Okay, so I'm utilizing the metastable condition state also, right? I'm using this 1 state to get the output as toggling output. Now it is useful, somehow it is useful, as toggle, right? So toggling input I have. Okay, I have given the truth table. Now how to make the characteristic table of this JK. Now in the characteristic table, what is changing? First of all, let's see. So J and K are the two inputs. Characteristic table means I need to find out what table. I need to find out the table where I have to find out the Qn plus 1. So I should have Qn, I should have J, I should have K. I have Qn, right? What is the Qn means? Initial Qn 0, it can be 0 or it can be 1. So memory, that is basically memory, and Jn can be 0 and 1. So I have 3 variables, so 8 states, just like in the previous case, 0 0 0 1 1 0 1 1. I'll assign the memory Qn as 0 to this right now, and I'll take memory as 1 right now, and I'll take the same condition 0 0 0 1 1 0 1 1. Okay, this is how I'll make the characteristic table, and it's time to find out the Qn plus 1. What is the next output coming to be, next state Qn plus 1 going to be? So Qn plus 1, what is it exactly happening? Qn plus 1 is Qn only, right? So Qn plus 1 is Qn only if it is having a clock 0 with clock 0 and clock 1 with J0 and K0, right? So Qn plus 1 is Qn in these two conditions. So see, Qn is 0, I'll be having whatever I have at the Qn only, right? So what is Qn? Memory. Memory is nothing but the J value, the first value itself. I'll be taking that 0. Okay, so the J0 will be given over here if I'm having 0 over here, right? So that 0 is represented over here, and Qn is 0. I don't care basically whether the J values or K values are 0 or 1. So they are basically the memories. Memories means these values, right? Qn values. So all this one will be over there, and here also you can see this is what I'll be having over here, like this. So these are all Qn plus 1 values going to be. Okay, and in this case, when Qn is 1, what is happening when Qn is 1? Qn is 1, and what is the J and K values? J is 0, K is 1. J is 0 and K is 1. Okay, J is 0 and K is 1. What is happening to J is 0 and K is 1? What is the Qn plus 1 going to be when the Qn is 1? I have J is 0, K is 1, and I have Qn plus 1. Next state coming to be 0. But since I have the Qn as 1 here, I can say that value, whatever the Qn value will be there, that value will be there, I'll be getting over here, right? So the memory. So 1 is basically going to be there, and here 1, I have the Qn as 1, the memory is 1. 0 0 and 0 1 is basically toggled, 1 to 0 over here, and this is what I'll be getting, right? Again 1 over here, right? And whenever J and K are 1, what am I getting? whenever the j and k are 1, I'm having qn complement. So qn is 1, I'll have qn complement of that. Okay, so I'll have qn complement, which is nothing but 0. So this is basically qn complement. Here also see, this is qn value is 0 when j is 1 and k is 1. What is qn plus 1? Qn plus 1 is a qn complement. Okay, so in order to easily remember, what you need to do, you need to look at the truth table, don't by heart how we are getting these things. Okay, so let's see how we are having these values. Fine, so qn plus 1 is qn only if I'm having clock as 0. This is clock as 0, or qn as 0, or clock are 0. In that case I'm having qn only. And when clock is 1, j is 0, k is 0, I have qn, j is 0, k is 0, I have qn only, right? The next state is going to be qn only, so it is going to be qn only, the memory. And j is 0, k is 1, I'll be having the qn plus 1 as the 0, right? Qn plus 1 is 0, j is 1, k is 0, j is 1, k is 0, j is 1, k is 0. What are we having? Qn plus 1 as 1, qn plus 1 is 1, j is 0, k is 1, I'll have the qn plus 1 as 1. Now everything is same. 1 is 1 0 means I'll have 1, 0 1 as means I'll have 0. See what I'm doing here, I'll give you important information here. These 4 data bits, these 4 are not going to change anytime. Whatever the qn values are, if I have 0 and 1, I'll have the next state as 0 only. If I have 1 as 0, I'll have the next state as 1 only. Okay, so they are identical, I can say that. Okay, identical. So you can verify after drawing the characteristics table, you can verify whether you have done correct or not by using these important things. Okay, so in this way I'll be having all these important things. See again here also, when j is 0, k is 0, I told you qn plus 1 is qn, right? So see, j is 0, k is 0, I have the qn plus 1 as qn only. Qn is 1 here, that's the reason I have written 1. Okay, here also j is 1, k is 1, qn plus 1 is qn complement. So qn complement means what do we have? Qn, I'll have 1, I have complement of that is 0, right? 0 complement 1, that is the reason how I have written 1. Okay, so in this way I'll plot out the characteristic table. Now using this, let's see the excitation table. Now I need to find out the excitation table of the JK flip-flop also, but we don't require the excitation table of JK flip-flop. Why? Because in conversion of the SR to JK flip-flop, if suppose in exams, suppose they are saying any conversion, it may be from SR to JK or D flip-flop, whatever it may be, whenever they are asking you convert from one flip-flop to another flip-flop, you need to find 2 important things. First of all, see what is the available flip-flop you have. So if I am talking about available flip-flop, available flip-flop is SR flip-flop, right? Now whatever the flip-flop you have available, for available flip-flop you need to find excitation table. Okay, you need to write the excitation table of available flip-flop, and you need to write the characteristic table of the required flip-flop. So characteristic table means you need to convert SR to JK. So you should have a characteristics of a JK. Your final flip-flop should have a characteristics of JK. So therefore my I have to take the characteristics table of the JK flip-flop. Okay, and the inputs must be SR only. So using the inputs SR, I have to make a characteristics of a JK flip flop. Did you get that? So the required characteristics of the table of the JK flip flop, we have the required flip flop as JK flip flop. So whatever the flip flop is to be made, the required flip flop is what the final flip flop. So our flip flop, okay, let's say that we have a flip flop. Now for this flip flop, okay, I don't know what the construction it has. It should have a characteristics of a JK flip flop and excitations of S and R. So I'm basically converting this S and R, which have two inputs. Okay, I'm converting that to a J and K. That means if I look it in the overall figure, I have the same outputs. Okay, I have this connection right now. Okay, now it is called as a JK flip flop. This is SR flip flop internally, and the total connection should be called as JK flip flop. That means this flip flop must have a characteristics of JK. So therefore you need to write the characteristic table of JK. And inputs, these inputs are given through these excitations called S and R. They are the inputs. So excitation table of SR flip flop must be taken. Okay, so remember that. So first try to write the excitation table. What is excitation table? How do we write that? I'll take Qn. Using Qn and Qn plus 1, we need to find S and R, right? So that is what the SR flip, this excitation table is saying. So using Qn and Qn plus 1, I need to find S and R. So 0 0 0 1 1 0 1 1. What will be the S and R? Now to write this excitation table, to fill up this excitation table, you need to have a good knowledge on characteristic table. Now to fill this characteristic table of SR flip flop, suppose we have the SR flip flop over here, right? So to fill this characteristic table, you should have a knowledge on truth table. So to write the truth table, you have to see the what is happening exactly in the SR flip flop. I already explained you very well with all the clear explanation in my plus courses. So do check out that courses, 15-minute long sessions, 30-minute long sessions. Do check it out, it will be useful for you. Okay, I have given you a lot of important questions even there itself, so that it will be practice for you. Okay, fine. So what is the excitation table? So excitation table is something like this. We have 0 don't care, 1 0, 0 1 don't care, 0. Okay, so let's see what is that exactly. Let's try to write that excitation table in this case. Okay, everyone try to fill up this particular table, excitation table, first of all, for this SR flip flop. Okay, it will be 0 and 1. I have filled up, and this will be the don't care, right? This will be the don't care, this will be the don't care. 0 and don't care, 1 and 0, right? 1 and 0. And for Qn is 1 and Qn plus 1 is 0. What will be having? We shall have 0 and 1. 1 0 1 1 0 1 0 0 1, and 1 1 means it will be don't care 0, opposite to that of previous case, don't care 0. Okay, so this is what we'll have for excitation table. Now for a characteristic table of the JK flip flop, how do we draw the characteristic table exactly? Let's see. For the JK flip flop, this is the characteristic table of the JK flip flop. Okay, I'll be drawing that. Okay, I'll just write it over here, refer previous slide. Okay, why to waste time if we have already over here, right? We have the same figure over here, right? So I have the JK flip flop characteristic table, and I have the excitation table of SR flip flop. Now what I should be doing with these two tables? Now we need to find out the final table right now. Final table means for what table? I am preparing this one table which is for the final flip flop, which is the JK flip flop. So the combination table of after processing, I'll be having a JK flip flop made out of SR flip flop. For that table, for that flip flop, I need to make a table right now. So what is that table going to look like? Let's see that. I'll just use these values Qn and J, everything whatever we have over here, and I'll just try to see that. One second, guys. Okay, and we have this table over here. What I am going to do here is, this is slightly different right now, so don't get confused with this. Okay, so it will be little confusion for you guys. Okay, first of all, write down this characteristic table. What you should do is, you should have to note down that characteristic table, and what I'll do right now is a bit different with what we have seen in the previous case. Okay, see, I will try to write the S and R also in this characteristic table. So what is the excitation table? Excitation table also we have Qn and Qn plus 1, right? So in excitation table we have Qn and Qn plus 1, and this is S and this is R. 0 0 0 1 1 0 1 1. What is S? S is 0, don't care, and here it is don't care. 0 0 1 1 0 1 0 0 1. This is what we are having for the excitation table. Now this is the characteristic table. From here to here it is the characteristic table. Okay, this is the characteristic table. Now what I'll do here is, I'll write these two columns S and R, two new columns S and R. Okay, I have S here, R here. Okay, now for the same values of 0 and 0, Qn is 0, Qn plus 1 is also 0, Qn is 0, Qn plus 1 is also 0, Qn is 0, Qn plus 1 also 0. What are the values of S and R? 0 and don't care. So S and R will be 0 and don't care. So that I can write it like that, right? So I can make the circuit, make the table something like this using the same constructions we have. So same logic circuits we have. So tell me, Qn is 0, Qn is 1. Okay, Qn is 0 and Qn plus 1 is 1. Qn is 0, Qn plus 1 is 1 means I'll have S as 1, R as 0. S as 1 and R as 0, right? This is what I'll be having. And see, Qn is 1, Qn plus 1 is also 1. Qn is 1, Qn plus 1 is also 1. Both are 1. Don't care and 0. Don't care and 0. I'll be having don't care and 0. Okay? Don't care and 0. Qn is 1, Qn plus 1 is 0. Qn is 1, Qn plus 1 is 0. S is 1, S is 0, R is 1. S is 0, R is 1. Right? And similarly, I'll have 1 here, right? So, Qn plus 1 is 1, I have 1 again here. 1 is always don't care and 0. So, therefore, I'll have it don't care and 0. I'll have Qn is 1 and Qn plus 1 is 0. Qn is 1 and Qn plus 1 is 0. Qn is 1, Qn plus 1 is 0. 1 0, 0 1. So it will be 0 and 1. Right? So this is what the final table looking like. So I have written S and R using my previous excitation table in this required characteristic table. So the characteristic table is clubbed with excitation table and the final table has come right now. So using this final table, what I have to do, I have to make up these tables, okay, or I have to make up this k map, sorry, okay. I need to find out a relation between jk and sr, okay. So then only I will know what is exactly present between the jk and sr, okay. So let's see what is that happening right now. So I'll first take a k map where I'll use qn, j and k. So I'll use these three variables in this case and I'll get the k map. So 2 power 3, right? So 3, so basically 2 power 3 is basically 8 cell k map, okay. So it's 8 cell k map. So let's try to find out, draw this k map first of all. Okay, I have this k map and I'm building that using qn and jk, right. So I'm converting it in from sr to jk. So I will write the final jk values, okay. What are the values? So j and k, okay. Now this is jk means I'll have 0 0 0 1 1 1 1 0. This is 0, this is 1. That means this j complement k complement, j complement k, j and k, j k complement. Like that, this qn complement this qn, okay. Now when qn is 0 and jk are also 0, I need to find out the value of s. So for s I have to find out one, I have to make a k map. For r also I have to make a k map, right. So for qn is 0, j is 0, k is 0, I can find out what is s, I can find out what is r. So what I'll do is I'll just take the same map over here. So it will be something like this. Okay, and I'll be using this k map right now. See, I'll be using this k map for finding s, value, and I'll use this k map to find the r value, okay, relation with the r and relation with the s. So let's fill up this table. S and R, I have two values S and R. I have to find out qn is 0, j is 0, k is 0. So what is happening when qn is 0, j is 0, k is 0? What will happen in this cell to the s value? Qn is 0, j is 0, k is 0. What will happen to the s? S is 0 right now, right? So s is 0 means I have to put it in the cell only, right? So write that value in the cell. We will write that value s equals to 0. Right, so that what I will be writing. See, qn is 0, j is 0, k is 1. Qn is 0, j is 0, k is 1 means this is what s is again 0. S is 0 here also. 0, 1 and 1. Qn is 0 and basically this is 1 and 1. 0, 1, 1 means I'll be having s as 1, r as 0. S as 1, r as 0. That means I'll be having s as 1, r as 0. I'll meanwhile fill up these two tables also. I'll be having don't care and don't care. Don't care and don't care will go and sit here, right? Don't care and don't care. So this is 1, this is also 1, right? So what is happening? 1 0 0, 1 0 0, don't care and 0. So I'll have don't care here, I'll have 0 here. And what is happening meanwhile in this? 1 0 1, 1 0 1, I have 0, I have 1, I have 0, I have 1, I have 0, I have 1. Similarly I'll have here 0, I'll have here 0, I'll have don't care, I'll have 1, I'll have 0. right? So this is how I'll be finding for S and R values the K map. Okay, I'll plot the K map like this. Okay, now you need to do the grouping. Which two will be grouping? See here, 1 and 1. I'll have a grouping over here, a duo. So what is that equation going to be? What is that equation going to be? S equals to, what is common in both of them? Qn complement is common. This is Qn complement. Qn complement. What is common? Another complement. What is another minterm complement? Same, 1 is common, that is j is common, right? K is changing from 1 to 0. So it is Qn complement into j, right? And this is what I'll be having for the S value. Okay, S relation with j. Okay, and what is the relation of the R with K? We need to find it out, right? So what is the grouping? First of all, what is the grouping? This is the grouping, 1 and 1. If I have grouping like this, 1 and 1, then what is the expression, Boolean expression here? It is Qn, it is Qn only, right? This is Qn, this is common, Qn into K, right? So K, basically Qn into K. So this is basically the value of R going to be, I'll say that. So R equals to Qn into K. So S value relation with J, R value relation with K. So I have relation with J and K values, SR relation with J and K. So let's see how are we manipulating that exactly. I am writing two flip-flops. I am having two terminals of the one flip-flop, SR flip-flop. Okay, let's say it is negative triggered. Okay, and I have the clock. This is basically the clock, and I have these terminals right now connected to the J and K. How am I connecting? Let's see that. This is Qn, this is Qn complement. S is Qn complement times J, right? So we need to have an AND gate between the Qn complement and J. So I'll have a small AND gate here, and the output of that okay, this is J, and another input to this J is basically the Qn complement. That means this is what the circuit going to be. This Qn complement will go to here. I'll get Qn complement J, and that is what S equals to S. Now similarly, what's the value of R? Qn into K. So I'll have an AND gate here, and one input is K, other input is Qn, right? So this is the circuit, final circuit. I have converted this SR to JK. That's it, nothing else required. So you have found a relation between S and J, means similarly R and K, means the game is over. Okay, so you can, like this, you can easily do lot of conversions, not only for SR to JK. Okay, one conversion I have given you, JK to D flip flop also. Okay, so do check it out how this conversion is happening. See, for JK flip flop means I have to find out the excitation table of JK. Try to find out the excitation table of JK. Try to make the excitation table of the JK. I have given you the excitation table of the JK here, and I am converting it to JK to D. That means the required flip flop must be having characteristics of the D flip flop, right? So D flip flop characteristic table, this is the characteristic table I have given. Try to write the truth table of the D flip flop and again make the characteristic table, and from there make the excitation table just for your confirmation. Okay, do that and find out how do you convert the JK to D and what are the complements, what are the values of the J and K you are getting in relation with the D. Okay, try to do with the K maps. You will be having solving this question in what I have given over here. Okay, in the same manner what I have given in this slide, you will be getting that operation conversion of one flip flop JK to D. Okay, so at the end you will get a circuit something very similar like this, right? So the J value will be nothing but D data input, and the K is basically the complement of whatever the data. If it is 1, the K will be having the 0 like that. Okay, and the next state, the Qn plus 1 is nothing but D value only. Okay, that is the important thing in this excitation table of the characteristic table of the D flip flop. Okay, the Qn plus 1 is basically D. Okay, if it is 0, it will also be 0. It will be 1, it is also 1 like that. Okay, it doesn't depend upon the memory. Okay, so this is basically the flip flop conversion happenings in the digital circuits. If you have any question regarding these things, do let me know. This will be really useful, and you can remember this trick for the complete rest of the preparation time also. Okay, so don't get confused. This is important thing regarding the digital electronics. If you have any questions regarding this, do let me know in the comment sections, and also check out my special classes and Unacademy Plus classes every day, and I'll be conducting the live classes every day from on Tuesdays. If you want, do check it out. On Tuesdays I'll be conducting mock test analysis sessions. Mock test analysis. So every Sunday I'll be uploading the mock test. Every Sunday is a mock test from now on, from this 24th onwards. So from November 24th we'll be having the mock test starts on Unacademy Plus. On Tuesday I'll be discussing a mock test analysis, and this is at 3 p.m. Okay, and every day at 9 p.m. I'll be holding some special classes. These are absolutely free. You can watch them on Unacademy app itself. Download the Unacademy app, and every day at 7 p.m. at 5 p.m. at 2 p.m. I'll be conducting the plus sessions, and these plus sessions include previous year question explanations and MCQ discussions, revision courses. Now what you guys will have to do is, do not try to get panicked by looking at the syllabus. Try to revise lot of the things. December is meant for revision only. Okay, if you are practicing with what strategy I have given so far, you will 100% get a good concept on whatever the concepts I have told you. Okay, backside questions. Okay, textbook backside questions. All these things I am discussing at 7 p.m, 5 p.m, 2 p.m, and also at 9 p.m. Okay, so each will be 90 minutes or 60 minute sessions. 60 minutes to 90 minute sessions. Okay, do attend these sessions, and you will really feel confident after finishing the classes. Okay, and if you don't get if you have some doubts regarding these things, you don't get some concepts questions or something like that, what you need to do is always message me on Unacademy app itself. Okay, it will be really useful for you as well as for me. I'll clear all your doubts regarding these things. Okay, whatever the such things we have discussed, okay, that will be given back to you. fine. And that's it for today's class, guys. If you like my classes, do let me know, and how the class is running. And if you have some suggestions, if you want me to teach some good concepts regarding other subjects as well, suppose if you want me to talk about hysteresis effect or something like that, what you can do is you can message me on the Unacademy app, and I'll be replying to that, and I'll try to put that explanation in the class itself. I'll make a separate 15 minutes 30 minutes class, a YouTube class, maybe we'll try to do that, and I'll explain that topic over there. So comment down in the comment section below what class I have to be taking next, or what topics you are feeling difficult with, and I will try to explain that topic to you in a very easy manner and in a very competitive exam manner. Okay, so completely exam point of view only. Don't neglect this opportunity. Try to attempt as maximum mock test as possible. Try to attend all these things. Okay, so that will be really useful for you. So that's it, guys. So if you have any questions, so do let me know. Okay, so that's it for today's class, guys. Thank you.